All right, so we're going to be starting today with this is lesson 3. We're going to be talking about continuous interest. All right, so continuous interest is essentially we took the formula from yesterday, our compounded formula, right? So we had our amount equals our principal times 1 plus my interest rate divided by the number of times we compound, all raised to the number of times our number of years, okay? And what's going to happen here is what happens as we take this number, we keep increasing it, right? So if we went from if we went from annually to monthly, quarterly, daily, weekly, what if we compounded it even more? What if we took that number and went to infinity? Instead of breaking it down for each day, for each hour, for each second, we continue on until it's infinite. So for instantly, like for every instant something happens, that's how many times we want to compound. We're continuously, we're always compounding. Okay. So that's what this is saying, right? We're just basically, hey, E is a number. As we take this formula here, as we go to infinity, what's going to happen is my formula is going to go to the number E. And all E is kind of like pi. It's a, let's do this so you can see it. It's 2.71828182846, and it continues on. I know the calculator stops there, but it just keeps going on forever, okay? For the purposes of this lesson, though, you just need to know this formula here, where P is my starting amount, R is my interest rate, and we use decimals, right? We're not going to write if it says 4.7%, we're not going to write that. We're going to write 0.047. And then T is, of course, our time in years. And all of this is written down already, given to you, so you don't have to have that. You don't have to write that down. Just remember, E is a number. Okay. So whenever you see the words compounding continuously, use this formula. Let's jump right into it. Okay. So Matthew invested $5,800 into account, paying an interest rate of 4.9% compounded continuously. Right. Compounding continuously. Assuming no deposits or withdrawals are made, how much money to the nearest cent would be in the account after 7 years? Okay, so let's take this one step at a time, right? So if I want to go through this, right? So our initial investment is $5,800. We're making 4.9%, but we're not going to write 4.9. We're going to write 0.049. We're compounding continuously. There's another key piece of information here. And then we want to go for 7 years. Okay, I'm looking right at my formula here. I'm just going to copy it down, right? So it's now A equals my principal times E to the R times T. Well, my principal in this problem is 5,800. So I'm going to go and highlight that. We have that times, I'm going to write out the formula and then I'll color coordinate it. Times E to the, we already said it was 0.049, raising that to the 0.049, and we are going for 7 years, so we're going to use 7, okay? So let's go, I'm going to go back now and highlight things. Right, this whole thing right here, this is my 4.9%, my $5,800 of initial investment. We are compounding continuously, so we're using the formula with the letter E, and we're going for 7 years. Okay, so we'll go ahead and plug this into our calculator. So we have 5,800 times E raised to the, in parentheses, 0.049, close, times 7. So we got 8,173.1788. Okay, so it's asking us to round to the nearest cent. Okay, so that means I'm going 2 decimal places. This 8 is going to tell me if I round up or leave it alone. So my final answer is going to be approximately $8,173.18. Okay, so it should be pretty similar. If you feel comfortable with the compounding daily, monthly, weekly, annually, we're just using a slightly different formula, but it's all coming from the same thing. That's example 1. Let's do one more problem just like this. Example 2 now. Now, Samantha invested $67,000 into an account paying an interest rate of 3.9%, compounded continuously, assuming no deposits or withdrawals are made. How much money to the nearest dollar, so we're rounding a different place, would be in the account after 7 years? So same number of years. Okay, so this again, my amount is going to be my principal because we are doing continuous. E, we'll write 0.039 for my interest rate times 7 years. Whoops, that's actually R times T. Okay, so we have 67,000 is my principal. Skipping ahead there, sorry. We have 67,000. I'm going to raise this to the 3.9%. We'd write it as 0.039. That's just coming from this part right here, right as a decimal. We're compounding continuously. That's why we're using the letter E. We have 7 years. So we're going to multiply this by 7. Okay. Go and plug that into your calculator. I would highly recommend using a calculator for this part of this quiz, anytime you for this test. So we have 67,000 times the letter E, all raised to the 0.039 times 7. So we have, get the right pen, 88,031, and then 0.3164, right? Again, now we're rounding to the nearest dollar. Okay, so again, my dollar place is right here. So you need to know like your tens, your dollars, to the nearest dime, to the nearest cent. You got to be able to do that on the fly. So if you round now, my answer is going to be approximately $88,031. Okay, that is example 2. All right, last example. Kevin invested $860 in an account paying an interest rate of 4 5/8% compounded continuously. Deandra invested $860 into an account paying an interest rate of 4 7/8 compounded monthly. Okay, so giant red flag. We're using 2 different formulas, right? So Kevin is going to be using the formula with the letter E. Deandra is going to be using the formulas from our last lesson. Okay. After 17 years, how much more money would Deandra, there's a typo, Deandra, have in her account than Kevin to the nearest dollar? Okay, so basically what we're doing is we're doing our Deandra total minus our Kevin total. Okay, so let's do it step by step now. Okay, Deandra invested $860. We're told that she compounded monthly. So we're going to be using our original formula. So it's going to be 1 plus my interest rate over the number of times we compounded. So in this case, it's going to be 12. All raised to the number of months compounded times the number of years. Right? So that's our formula from yesterday. Right? A equals my principal, 1 plus my interest rate over the number of times compounded, n times n. The formula for Kevin is going to look something like this. This is what we're talking about today. My principal, e to the r times t. Okay. Well, my interest rate, well, it's in a fraction, so we need to convert that. So if we say 4 7/8, I'm going to use my calculator to do this for me. I'm going to cheat a little bit. We do plus 7/8, and we do, so that's going to be 4.875%. 875, or 0.04875. So we have 0.04875. All right, so there's our monthly compounded formula. So if we go ahead and plug that in, we get 860 minus 1 plus 0.04875 divided by 12. And that is supposed to be not a minus. Sorry. Let's go make that a parentheses. Close the parentheses. And now we want to raise this to the 12 times 17. Okay. So we get roughly 1,966 point. Let's go 4 decimal places just so we don't round. 4861. All right, so Kevin was compounding continuously. Okay. Again, Kevin also had an interest rate of 4 5/8. Again, I'm gonna cheat a little bit. I'm gonna do 4 plus 5 divided by 8. We'd have gotten 4.625%, or if you want to write that as a decimal, 0.04625. Okay, so again, this is compounding continuously for Kevin. So we have 860 times E. We're going to raise that to the 0.04625, all raised to the 7 times 17. Bigger erase than I meant to use there. Okay, so we have 860 times E, all raised to the 0.04625 times 17. So we'd have gotten 1887.8. Oh my goodness. Fat fingering it a lot tonight. All right, so we're going to stop there. Okay, so we just basically want to subtract those two numbers. Sorry, we have 1,966 minus 4861. We have 1887.8282. So it should be approximately $78.6579. We want to round to the nearest dollar. Okay, so this is the 8. We're looking at the 6 to round up that 8. So my final answer is going to be roughly $79. Okay, so again, to recap, that was a lot. We found how much Deandra made in her account. We found out how much Kevin made in their account. We're told that Deandra made more money in the account than Kevin after 17 years. So we subtracted them. So Deandra, after 17 years, would have $17 more than Kevin based on this situation. Okay. If there are any questions, feel free to email me, and I will see you guys later.